Hello, Algebra 2. This is Unit 7, Day 3, and in our first day of this unit, we studied the empirical rule, which is right here, and we found probabilities based on the empirical rule. And on the second day of the unit, we started studying z-scores and finding probabilities based on z-scores. So today, we're going to expand on that. We're going to use the z-score table, and we're going to find the probability based on the z-score above a z-score and between z-scores. We're also going to compare two sets of normally distributed data using z-scores, and we're going to use z-scores and probabilities to solve real-world problems. So here are the steps that we used yesterday to find the percent of values below a certain value. Number 1, we labeled the bell curve with the mean in the middle, and we added the standard deviation 3 times and wrote those values on the right of the curve. Then we subtracted the standard deviations 3 times from the mean, and we labeled those values on the left side of the curve. Then, if your value lands on one of the standard deviation values, you can just use your empirical rule, and if it didn't, you're going to use your new z-score formula, x minus mu over sigma. Remember that mu is the mean, and sigma is the standard deviation. So first, let's do a practice problem from day 1 using the empirical rule. So we have girls in 5th period who have a mean height of 5.5 feet and a standard deviation of 0.2 feet. So you always want to put the mean right in the middle, 5.5 feet. And I'm going to draw my standard deviations. And I'm going to add 0.2 to 5.5, so I'll get 5.7, 5.9, and 6.1. And then on the left, I'll subtract my standard deviation, so I'll get 5.3, 5.1, and 4.9. And next, it says to shade the values between 5.1 and 5.5 feet. So I can see I have this section and this section. And if I look back at my empirical rule, that means I'll be adding 13.5% and 34%. So 13.5% plus 34% is going to give me 47.5% of the girls between those two heights. And that was pretty quick, so let's go straight to the next page. And on the next page, we're talking about a corn chip factory that packs bags that are normally distributed weights with a mean of 12.4 ounces and a standard deviation of 0.15 ounces. So again, you want to put your mean right there in the middle. And let's draw the other standard deviations. So adding 0.15, we get 12.55, 12.7, and 12.85. And then subtracting your standard deviations, you're going to get 12.25, 12.1, and 11.95. So for problem 2, we want to shade the percentage of bags that contain less than 12.64. So you can see that doesn't land exactly on the standard deviation, so you have to estimate. There's your 12.64, and then you want to shade everything less than that. So we're going to use your z-score formula now. Z is going to be x minus mean over standard deviation, and your x is 12.64. The mean you were given is 12.4, and you're going to divide that by your standard deviation 0.15. So you should get a z-score of 1.6. And then you're going to use the standard normal probabilities table to find the area associated with the z-score in problem 3. So for 1.6, you get 0.9452, which means 94.52% of the bags contain less than 12.4 ounces. Okay, so I want you to go ahead and read problem 5 and see what you're looking for there. Looks like you're looking for the likelihood the bag will contain between 12.1 and 12.76 ounces. So go ahead now and label your axes again with the same values. So you still have the same mean, 12.4. And you add your standard deviations. Okay, so this time you want to be between two values. So you can see the 12.1 lands right here on the 2 standard deviations below the mean, and 12.76 is not exactly on a standard deviation. So you estimate and you color it in. So we're going to find the z-scores for 12.1 and for 12.76. So you want to grab your formula and plug those values in. So for 12.76, your z-score is 12.76 minus 12.4 over 0.15, and you get 2.4. And then your z-score for 12.1 is 12.1 minus 12.4 over 0.15, and you get -2. And then you're going to use those z-scores to find your probability. So the probability that you are less than 12.1 ounces, you're going to look on your z-score table at -2, and you get 0.0228. The probability that you are less than 12.76 ounces, on your z-score table you're looking at 2.4, and you get 0.9918. So you're going to subtract your two probabilities. You get 0.969, which is the same as 96.9%. Okay, and then you can stop there and you can go on to the next video.